All right, so we're going to look at starting at number 5. So the argument in items 4D through 4F shows that a sequence of rigid motions maps triangle A prime B prime C prime to triangle DEF. The dilations in item 4C followed by the sequence of rigid motions shows that there is a sequence of similarity transformations that maps triangle ABC to triangle DEF. So by the definition of similarity, triangle ABC is similar to triangle DEF. So we learned previously that there are 6 criteria showing that the triangles are congruent. And so we had the 4 on the side wall. So we had our side, angle, 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 side, side, side. We had hypotenuse leg. And then we can go through and show that everything is congruent to show the triangles are congruent. So yesterday we looked at angle similarity. So now we're going to look at side similarity criterion. So for this, we're going to look at how do you think the side similarity differs from side congruence. So when we were using side for congruence, we had 2 sides that were congruent, and then the angle in between those 2 sides was congruent, right? So how do you think that's going to be different when we're dealing with triangles that are similar? Are the sides, how is that going to work? Are they going to be the same? Are they going to be congruent? Tori said the key word. The sides are going to be proportionate. So what does that mean? When the sides are proportional, they're similar, they're increasing, decreasing, how? Equally by the scale factor. Those are all key words. Good. All right, so in A, what would be something good to put there for all our friends who are not here today because they're tracking it?
I got some just put on understand. Okay.
So what do we want to put in A? So how are they different? Side congruence is going to be different from side similarity. So in order for the sides to be proportional, how does the scale factor involve there? How does that come into play? Right, so they'll be increasing, decreasing by the same amount. All right, so B says state what you think the side criterion would say. So kind of think back to what we said about angle similarity postulate yesterday and how our congruence postulates read. How do you think this one, what do you think this one's going to say? So if, what did we say yesterday for angle similarity? How did that postulate read? You have to look back in your notes. Turn the pages. All right, so how would this one read then if we're following that same format? So if two sides, right? Because it's side side. So if two sides. And is it any angle or is it a specific angle that has to be congruent? So if two sides. All right. So these two sides, I forgot. If two sides are.
Similar.
Or what's the key word that we use? Proportional. If two sides are. Two sides are proportional. And which angle? And that angle, what do those two corresponding angles have to be? I heard it. I'm going to add the word corresponding and the corresponding. All right, so if two sides, any two corresponding sides are proportional and the angle in between those sides are congruent, then what do we know about our triangles? They are similar. All right, so questions on that? All right, so now it says use geometry software to construct the following triangles with the given measurement. So I found something cool this morning. I have this on here. I'm pretty excited. If I can make it bigger, I'd even be more excited. All right, so I'm going to do.
Sophomores. On Thursday, there's a few homes in the church, plus I have preschool screen. Could you guys all park in the north parking lot, please? Is that possible? So I'll try to I'm gonna be on tomorrow, just so you might park that way so we can have parents out here. Okay. It's the parking lot. Yeah. Don't park nice for us on
All right, so all right, so what are the dimensions for our triangle? I have a line segment that's 4. What's the length of the other side? 6. All right, so I'm seeing if I can. I guess it looks good. B is 6. All right, so now what's the angle measure? What is it? 47. All right. So I'm not sure how to measure an angle. Mrs. Chester's having technical issues.
Maybe that little.
Maybe I need to do this one first.
Oh, that's neat.
Okay, well that didn't work out the way I wanted. All right, so I have my angles 47 degrees. So now I'm going to do and I think I can make it connect, but I don't know how. How do I change that distance? Oh, it keeps adding things. How do I make B go away? Okay, so that looks good, right? I have my triangle. This angle is 47 degrees. AB is 4. This one is 6. And then this, my C side is 4.38. So that's pretty cool, right? It only took me about 10 minutes to figure it out. All right, so I forgot what the point of the story was supposed to be. All right, so how about I give you some rulers and protractors? Let me pause it because YouTube probably doesn't want to wait. Back. All right, so from our triangles, we determined that the triangles are similar, and so we showed that all three corresponding sides were proportional, and all three angles are congruent, right? So if we are looking at similarity between triangles, do we need to show that all corresponding three sides are proportional, and all three angles congruent? And so we just need two sides and the included angle, right? So state the side similarity theorem. So kind of what we wrote earlier. If two pairs of corresponding sides are proportional and the included angle, the angle in between them, are congruent, then what do you know about the triangles? Not congruent. They are similar. So in F, let's write the side angle side theorem one more time. They do. How about it? Twice. So if two pairs of corresponding sides are proportional and the and the corresponding included angles are congruent, then the triangles are similar. So, in addition to writing that in your workbook, where else would be a good place to take note of this? And your VO, okay. All right, so questions so far. All right, so the last one, we're going to kind of go through and do the same thing. So what I want you to do, you and your partner, is to look at side similarity postulate. So create the two triangles that it's asking you to write. Think about what side triangle congruent says and what side similarity postulate is going to say. So think about what the wording is going to be. Think about why side works for congruence. So why would it work for similarity? Create the two triangles. Look at them. Are they similar? Are the sides, in order to be similar, the three corresponding sides must be proportional. And then what should that do with your angles? They need to be congruent, right? For both triangles, you can't have, just because the sides are proportional, if the angles don't match up, then are they similar? All right, so look at that. So answer 6A through F, and then we'll look at that. Are congruent between our, so angle B and angle F are congruent, angle A and angle E are congruent, and C and G are congruent. And so since all of the corresponding angles are congruent and all of the sides are proportional, because they gave us proportional sides, what do we know about our two triangles? They're similar. So now we've looked at three similarities postulates, right? I do have a boo-boo. We have angle, side, angle, side, and side, right? How did I get a boo-boo? I was changing the blade in the food processor and wasn't paying attention.
Food water?
Food processor. You chop food in it. Like you put it in and it chops it for you. Kind of like a blender. So now let's look at number 7 and let's determine the similarity postulates. Let me pause. Hold on. Actually, let me just